Hello and welcome to another Raspberry Pi tutorial by me, the Raspberry Pi Guy. In this tutorial, I'll teach you how to use this OLED display with your Pi. By the end of this tutorial, you'll be able to make it show everything from simple text to converted images. But first, let's take a closer look at this display. So this is a 1-inch monochrome OLED graphic display with a resolution of 128 by 64 pixels. This makes it perfect for displaying black and white text like you saw earlier, or as you're seeing now, small images. One of the benefits of using an OLED display over a generic liquid crystal display is the fact that it requires very little power and that it is a lot more flexible. You can display proper black and white graphics with it. It is designed by Adafruit and costs roughly £16. All the components used in this video are available from Pimoroni if you're in the UK and Adafruit if you're in the US. Links to where you can buy them from are in the description below. Here's what you'll need and a few close-ups of all the components. So, in this tutorial, you'll of course need a Raspberry Pi with Raspbian installed, and it is also worth noting that it will need to be connected to the internet in order to download the libraries that we will be using. Next, you'll of course need one of Adafruit's monochrome displays. Here is my one. For your information, you will need to do some very basic soldering in order to attach this row of pins on the back to the PCB. You can communicate with the OLED through either SPI or I2C. Today we'll be using SPI. You'll also need a breadboard of any size and shape, like this, as well as 7 male to female jumper wires, like this. And that's it. Now let's move on to wiring up our display. So the first thing you're going to do is insert your OLED display into your breadboard, like so. Make sure that it's nice and firmly in place. Now, grab one of your male to female jumper wires and plug the male end into the same row that ground is in on our OLED, like so. Then, plug the female end into pin 6 of the Pi, remembering that pin 6 is ground, like so. Now, set that down and grab another male to female jumper wire and connect V in on our OLED display, which stands for voltage in, to pin 1 on your Pi. This is our power line. Again, make sure that's nice and firmly in place. Now we're not going to connect anything to the pin on our OLED display that is marked as 3.3 volts, so simply skip over it and attach the pin labelled CS to pin 24 on your Pi. Pin 24 is one of the SPI lines. Again, make sure it's nice and firmly in place, like this. Now attach the pin labelled RST, the reset pin on your OLED display, to pin 8 on the Pi. Pin 8 is just one below ground. Next, set that down and grab another male to female jumper wire and attach the pin labelled DC on your OLED display, like so. And we're going to connect that to pin 10 on your Pi. And pin 10 is just one down from the one that we just did, which was pin 8. So pin 10's here. Make sure that's nice and firmly in place and secure. Now, grab your second to last male to female jumper wire and attach the male end to the CLK pin on your OLED display, that stands for clock, and then to pin 23 on your Pi, like so. Finally, take your last male to female jumper wire and attach it to the pin labelled data on the OLED, and then attach that to pin 19 on the Pi. Now this may all seem a bit complicated, but if you just go through it logically and check your wiring, then it should be fine. Here is a quick circuit diagram. So now that we've wired up our OLED display, let's get on to actually setting it up so that we can program it. We'll be communicating with our display through Python, but sadly the tools we need to do so aren't included in the default Raspbian image, so we're going to have to install them, and that is why you'll need an internet connection. The library that we're going to download in order to be able to use our display is called PyGoolGet. However, it depends on a substantial amount of other software, so I've created a simple program to install all of it in one go. More of that in a second. So first, boot up your Raspberry Pi and log in. You do not need to start up the desktop environment because we'll only be using the terminal. Let's get straight to it. First of all, we need to install Gitcore. This software will allow us to download all of the libraries that we'll need later. Most of you will already have it installed, but for those that don't, simply type sudo apt-get install git-core and then hit enter. Leave that to install, and then secondly, we're going to need to unblock the SPI pins on the Pi because they're unusable by default. We have to do this because otherwise we will not be able to communicate with our OLED display. To unblock them, we're going to have to edit the Raspberry Pi blacklist file. So simply type in sudo nano etc modprobe.d raspberry blacklist.conf, and that's the path to where the blacklist file is saved, and then hit enter. You should see this appear. We're now going to edit this line so that it has a hash in front of it. Mine already does, and make sure that yours looks like mine. Now exit with Ctrl X, and when it prompts you whether you want to save, press Y and then enter. In order for those additions to take effect, we will need to reboot, and you can do that with the command sudo reboot, and then hit enter. So after your Pi is rebooted, log in, and again remember that you don't need to start up the desktop environment. The next thing we're going to do is grab that all-in-one script that I mentioned earlier. Not only will it automate the installation of PyGoreGet, that library that we need, but it will also download 4 example Python programs to use straight away with our OLED display. So we're going to type git space clone, and then this URL is where all my code and the installation script is stored, and that is https github.com/the-raspberry-pi-guy/OLED, and then hit enter. That should take a few seconds to download. Once it has finished, you should have a new directory in your current one called OLED. So let's type ls, and we see there is OLED. So let's change into that directory, cd OLED. And if we type ls again, we'll see the contents of that directory. So we have a README with some basic information. We have a new directory with all of our Python examples that I'll get onto in a second. And then we have an OLED install.sh. And that is our installation script. Before we can use any of the stuff that we've just downloaded, we will need to run that. So we can run that by typing sh OLED install.sh and then hit enter. And we should see scrolling lines of text as the necessary software is installed. So I'm going to wait for that to finish, and I'll come back in a second. So now my installation script has finished, and we can get going with some of the Python examples that I've provided. So make sure that you're in the OLED directory. I'm just going to change directory now. And then we're going to change directory into that Python examples folder, and we can do that with this command here, cd Python examples, and then hit enter. Now let's list the contents of that directory with the command ls so we can actually see our Python programs. You should see 4 Python programs appear. I'll just explain what they do. So OLED text.py is the most basic. It shows you how to print text in various forms onto your OLED display. OLED clock.py displays a clock that scrolls to the date and alternates between the two. OLED IP.py displays your current IP address on the OLED display. And finally, OLED image.py can convert any image and then it will display it on the OLED display. That is why there's a picture file called Penguins included. That's just an example. I'm not going to delve into the code much. It's fairly simple and you can do that yourself. Here's how to use it and the outputs of the programs. So let's start with OLED text.py. Run it with the command sudo python OLED text.py and then hit enter. You should see this on your OLED display. If you take a look at the program, you'll see how it works. Now let's have a look at OLED IP.py. Run that with sudo python OLED IP.py. And you should see your internal IP address displayed on your OLED like this. Moving on to OLED clock.py. You run that with the command sudo python OLED clock.py just like this, and then hit enter, and you'll see this. Because that's in an infinite loop, you should exit by pressing Ctrl+C. And finally, OLED image.py. You run this with the command sudo python OLED image.py space and then the name of the image you want to display. So you have to have the image saved into the current folder, and then you simply write its name at the end of that command. So let's say that I wanted to display a picture of the car and the file was called car.png. I would run that by using this command, sudo python OLED image.py car.png. I've included a picture of a few penguins as an example, so we're going to run that. So in order to use that, simply type sudo python OLED image.py penguins 900 by 600.jpg and then hit enter, and you should see this on your OLED display. And so concludes this tutorial. We have covered a lot of ground, everything from wiring up the display to installing the libraries for it. Great work! My Python examples are very easy to modify, and I hope you do in order to see how they work and function. Thanks go out to several people, including Ryan Wamesley for helping me in a few areas, and Guy Carpenter for giving me permission to use PyGorget.